In this video, we're going to talk about how to use the chain rule to determine trig derivatives. The first rule is, if you're performing a trig function on an angle that isn't just x or theta, in other words, the angle isn't just the variable that you're taking the derivative with respect to, then you want to think of the chain rule this way. The derivative of f of g of x is f prime g of x, g prime x. Okay, so let's see what that might look like. To put it in slang, what we might say is give the derivative of the trig function and leave the angle alone, then multiply the entire result by the derivative of the angle. Okay, so here we go. This is a restatement of what we said on the previous page. So what if we had y equals the sine of x squared plus 1? Well, think of the outer function here as being sine. So we know the derivative of that is cos. So we do the cos of the angle. We just leave it alone. And then we multiply that by the entire result by the derivative of that angle, which is 2x. Now, it's important to know you're not going to multiply x squared plus 1 times 2x and then take the cos of that. No. What's happening is it's this entire result times 2x. So what I like to do is I like to put the 2x in front so as not to confuse me. So it's 2x times whatever the cos of x squared plus 1 is. So what if I have the sine of cos x? Okay, well, let's think of it. We've got f of g of x. F is the sine, and g of x is cos x. So the derivative of the outer is cos. Leave the angle alone. And then multiply that entire result by whatever the derivative of that angle is, which in this case is negative sine x. Again, I like to remind myself we're not multiplying cos x by negative sine x. Instead, we're multiplying negative sine x by this entire result. So just to not confuse myself, I like to put that in front. It's negative sine x times the cos of cos x. Okay, well, what if you're performing a power of a trig function? In other words, you have cos squared or sine to the 3, something like that. Well, what we're going to do in that case is we're going to put the exponent on the outside and then think of the chain rule as simply the power of a function rule. So something I see students are usually pretty good at is realizing that if y equals a function cubed, then the derivative is equal to 3 times that function squared times the derivative of the function. In other words, the derivative of block cubed is 3 block squared times the derivative of block. Okay, so what if we have cos cubed x? That becomes cos x quantity cubed. Put the exponent on the outside like that. Now we've got block to the 3. The derivative is 3 block to the 2 times the derivative of that block, which in this case is negative sine x. So just to make sure I don't confuse myself, this coefficient here is 3, this is negative 1, so I multiply them, I get negative 3 sine x times cos x quantity squared, which is the same as cos squared x. All right, let's kick it up a notch here. What if you have a combination of those? Then what we do is we put the exponent on the outside and work from the outside in. So for instance, generally speaking, if we have f of g of x and that entire thing is cubed, then we still think of it, the derivative, the same way. It's if we're given block to the 3, the derivative is 3 block to the 2 times the derivative of the block. Well, what's the derivative of f of g of x? We said it earlier. It's f prime g of x, g prime x. So what if we have y equals sine cubed of cos x? I take that exponent, I move it to the outside, so I've got the sine of cos x cubed. So in other words, I have a chain rule opportunity, a composite function, cubed. Well, the derivative of block to the 3 is 3 block squared times the derivative of the block. Well, what's the derivative of the sine of cos x? Go back to what we said earlier. The derivative of f, so since f is sine, the derivative is cos, then leave the angle alone, and then multiply the result by the derivative of that angle, which in this case is negative sine x. And then I like to simplify it a little bit. I have a coefficient here of 3, 1, and negative 1, so my overall coefficient is negative 3. Sine x, cos of cos x, and then I've got the sine of cos x quantity squared. That's actually the same as the sine squared of cos x. And I write it that way. Okay. Now let's really mix it up. If I gave you a composite function with 3 functions, so in other words, f of g of h of x, the derivative of that would be f prime g of h of x times the derivative of g of h of x, which, as we've already said, is g prime of h of x, h prime of x. So the chain rule, you go from the outside in and you keep on going until you're done. So in other words, block prime, f of a function prime is f prime of that function times the derivative of that function. Well, in this case, it's a composite function, so the derivative of it is g prime h of x, h prime x. An example would be this. We have the sine of the cos of 2x. So I have sine here, the derivative of that is cos, leave the angle alone. But now I have to figure out the derivative of this. Well, it's a chain rule opportunity. The derivative of the cos of 2x is negative sine of 2x times the derivative of the angle. So we have to keep on going until we've given the derivative of that innermost angle. And then we can restate it. We've got a coefficient of 1, a coefficient of negative 1, a coefficient of 2, so that's negative 2. And then we've got the sine of 2x, and then we've got the cos of 2x. And again, I like to put it that way because I don't want to think that I'm multiplying the cos of 2x by negative sine of 2x by 2, and then doing the cos of that. That's not the case at all. This is one entity, and I'm multiplying it by this, and I'm multiplying it by that. Okay? So again, we want to make sure we keep on working from the outside in, and when you've given the derivative of the innermost angle, you're done. So what if we had y equals the sine cubed of cos of x to the 5 plus x? Okay, well, that would be like saying y is the sine of cos x to the 5 plus x quantity cubed. In other words, bring that out there. This doesn't count as something you want to bring out there because it's within the angle. Okay? So the derivative of block to the 3 is 3 block squared times the derivative of the block. Okay, well the block is sine of different block. So the derivative of that is cos of that block times the derivative of that block. Well, what's the derivative of cos of a new block? It's negative sine of that new block times the derivative of that block. This is one big multiplication, including the 5x to the 4 plus 1. Now, I've seen people then multiply by the derivative of this, which would be 20x cubed. But that would be incorrect. The innermost angle here is that x to the 5 plus x. Once you've given me the derivative of that within that chain rule, you're done your chain rule. And now I like to put everything in a proper order. So this is negative 1 times 3 times 5x to the 4 plus 1. And then I've got the sine of x to the 5 plus x, cos of cos x to the 5 plus x, and then I've got this block squared, so I can call it sine squared of this block. Last but not least, one of the main things of knowing how to use the chain rule is knowing when not to use the chain rule. Sometimes it's a chain rule, sometimes it's a product rule, so it's important to know the difference. If you have f of g of x, that's a chain rule. If you have f of x times g of x, that's a product rule. So for instance, the tan of cos x, that's a chain rule opportunity. It's f of g of x. But if you have tan x cos x, that's a product rule opportunity because it's f of x times g of x. If you have tan x times the cos of sine x, that's a product rule. Tan x times the cos of sine x. But within that product rule, when you go to give the derivative of cos of sine x, you'll be using a chain rule. So it's important to keep in mind when to use it and how to use it, but then also when not to use it.